So this is part 2 of lesson 3.2, free body diagrams and net force. So this thing, determining the net force. We say that the net force is the sum of all forces, and then we use this Greek symbol called sigma, and sigma represents this operation called summation. That's just a fancy way to say that we use addition, right? So essentially, we're just adding forces together, okay? But we have to be mindful. We have 2 dimensions, okay? We have horizontal and vertical, so we add the vertical together in a separate computation, and then we add the horizontal together in its own computation. We never mix and match. We don't add vertical and horizontal at the same time. We only keep vertical with vertical and horizontal with horizontal. Okay, so essentially we say that the net force is just the final force after we take into account all the forces acting on the object. Another fancier way to say that is the resultant force, and we've heard that word resultant back when we spoke about vectors when we were first introduced to it. Okay, again, the acceleration is in the same direction as the net force, meaning when you have one vector that is considerably larger than the rest of them, and when I say the rest of them, I mean the opposite one. So if I'm looking at horizontal forces, one of those forces horizontally is larger than the other horizontal force, and therefore we say the acceleration is occurring in that direction, since there will be like a leftover force when we find the resultant, or aka the net force. Okay, so if we're looking at an example, right, and I wanted to find the vertical net force, I am going to say that F net, which is my net force, is the sum of all forces. Specifically, if we look at it vertically, it's these guys right here. So Fn plus Ff. Okay, so F net equals, so I have 5 newtons going northward plus, however, now this is where I need to be considerably mindful. The frictional force points in the downwards direction, indicating to me that I need to put a minus sign, so negative 5 newtons, and my net force in the vertical direction is 0 newtons. And I'm going to put a slash to my 0 so it doesn't look like the word on. Okay, that was just one direction though. Now we have the horizontal. So again, we're going to use the same formula. F net equals sigma F. Here we're going to add Fa plus F of F. Okay, so F net equals Fa is 20 newtons, okay, plus, now I have to be careful, right, because F of F is pointing in the negative direction towards the left, so I need to make sure this is minus 15 newtons, okay, and you should get a net force of 5 newtons horizontally. Okay, that should make sense because your acceleration is going to be towards the right, because that's the part where you have the unbalanced force going on. Okay, so that's how you find net force, using F net equals sigma F. Notice how I had to break it up horizontally, and I said, okay, F of A plus F of F, and I just have to be mindful of who has that minus sign. Same thing with vertical. I break it up using the same formula. Okay, and here I am adding the normal force. Oh, I'm sorry. The normal force and the force of gravity. Whoops, let's correct. Right, we want to make sure Fn and Fg go together. Those are the pairs, and Ff and Fa go together. Okay, so now let's actually talk about how do we find the net force. I know we just did that example together, but you have to consider each dimension separately. So again, you have horizontal and vertical. We have to be mindful of the direction of the forces, so anything that is downwards or to the left needs to have a minus sign put in front of it, because it's going in the negative direction, okay? And then you're going to add all the forces, because that's what that symbol sigma tells you, is to add them up, okay? And that's you're going to solve for F net. So this is not on your reference table, so I need you to copy it in somewhere. F net equals sigma F. This is a very useful tool when we are solving for the net force, okay? We are now going to do some examples. All right, so again, I know you don't see the diagram, but you do have this in your notes packet. So you have force of gravity equals 800 newtons. And then you have, oops, let me actually do a little better drawing there. Then you have force of tension, and I'm still not kind of meeting the cut there. The force of tension, right? And I'll just put just tension like that, okay? And that is equal to 1200 newtons. So according to our rules, we say F net equals sigma F. So F net equals 1200 newtons plus a negative 800 newtons. So that tells me that my net force equals 400 newtons, okay, and that means that it's going in the positive direction, right? So that's why I drew my arrow upwards. Okay, so that's one example. The next example would be the following. Okay, so I have the same thing, free body diagram. I have FAR, which that is the force of air resistance, 600 newtons. And then I have the force of gravity as 800 newtons. Okay, following the same rules, F net equals sigma F. F net equals, now I have 600 newtons plus a negative 800 newtons. Again, anything pointing downwards has that minus sign because that's a negative direction. So we'd say the net force is negative 200 newtons, meaning that the net force, if I was going to draw it, would look something like this. F net, right? It would point downwards, and I'll do the same thing up here. It would be 400, F net equals 400 newtons. Okay. Last example. So I have this box. So this might seem a little tricky, but I promise it actually is a lot simpler than we think. So I have 50 newtons for the force of gravity. My normal force is also 50 newtons. And I have this force of friction, and that's 20 newtons. Okay, so same thing. But now we have two dimensions going on. I have the x and the y, right? Vertical and horizontal. So I say F net equals sigma F. So let's take care of the vertical. So F net equals 50 newtons plus a negative 50 newtons. So that means that F net in the vertical direction is 0 newtons. Okay, so I'm going to write vertical. Okay, so essentially on my diagram, what I could do is the following. I just literally cross them out, right? Because they're equal in magnitude but in opposite directions. And the only thing that I'm left with is F of F equals 20 newtons. So really, my F net equals negative 20 newtons, right? And that tells me that my net force is literally the same length as that vector, and it is in the, it's pointing to the west, right? Because that's what our example has, okay? So now, let's talk about unbalanced forces. So we know unbalanced forces is a result of an acceleration. So during this acceleration, the object's forces do not cancel out. And that's what we're seeing is that one of those vectors has to be considerably longer than the opposite side's one. We say that the object is not in equilibrium. Equilibrium is a state where all forces cancel out. So clearly this is not happening. So the acceleration can be occurring when something is slowing down or speeding up. So that means that the acceleration has to be any number but 0. Okay? And if we use that formula, F equals ma, as long as this is not 0, right? Let's make the mass 1. Let's make the acceleration 2. We know that what's happening here? Oh no. We know that we'd end up with some force. Likewise, that's why we're saying that the net force can't be 0 because, as you tell, when I plug in something that is not 0 for acceleration, you have to end up with a net force. So if I have a net force that is not equal to 0, that means I have an acceleration going on, okay? Likewise, how we just said that, you also have these things called balanced forces, okay? So that means when objects are in, oh no, what is going on here? When objects are in equilibrium, so again, that's just a state in which all forces will cancel out. So this only happens in two states. This happens at rest and when an object is moving at constant velocity. So we say that there's no acceleration happening. That should make sense because if I'm at rest or moving with a constant velocity, how could I be accelerating? Okay, so that means that my acceleration has to be 0 meters per second squared and my net force has to be 0. Okay, and how we can prove that mathematically, if you use F equals ma, F equals, we can make the mass 1. If I make this 0 meters per second squared, right, uh, any number times 0 is going to be 0. Okay, so that's why we can say that's true. And that's for balanced forces. So balance just means that they're all equal. Okay, unbalanced means that they're not all equal.